The Albury-Wodonga Hume Freeway project involved a 17.4 kilometre upgrade of the Hume Freeway from Wodonga in Victoria to Wodonga in New South Wales. The works have been delivered as one project under two contracts managed by the state road authorities, being VicRoads in Victoria and RTA in New South Wales. At the time of completion, the $524 million project was Australia's biggest ever regional road project. It was funded by the Australian Federal Government. The Victorian section of the work, managed by VicRoads, included the construction of 12 bridges across the Murray River floodplain, including twin bridges across the Murray River. Albury Group contractors were the successful tenderer for both design and construction contracts, which were awarded in early 2005, with works commencing on site in April 2005. Historically, this is the first time twin bridges have been constructed simultaneously across the Murray River between Victoria and New South Wales. What you're about to see is VicRoads time-lapse photography of the construction of one of the Murray River bridges, the Melbourne-bound bridge, with supplementary still and aerial photography of the site at various stages of construction. The design and construction of the $15 million Murray River bridges, which are segmental launched post-tension box girder bridges, was sublet by the principal contractor Albury Group to Fitzgerald Constructions in Melbourne. The 195-metre-long Sydney-bound and 205-metre-long Melbourne-bound bridges have 9 and 11 segments respectively. Each bridge has 4 spans between 40 and 57 metres in length, with segment lengths ranging between 9 and 24 metres. Both bridges were constructed and launched from the Victorian side. Construction on the Sydney-bound bridge commenced in October 2005 and reached the New South Wales abutment in May 2006. The Melbourne-bound bridge, which is the subject of the time-lapse you're about to see, commenced in May 2006 and reached the New South Wales abutment in November 2006. Each bridge segment was constructed in a sequence of 4 stages, being segment cast, segment cure, connecting of one segment to the next, and pushing out of the combined segments. Each segment of the box girder is cast in 2 stages. Stage 1 consists of a base and walls or web, and Stage 2 is the deck. Cycle times for the cast and launch of each segment are between 10 and 12 days. A high-performance 50 MPa VicRoads concrete mix is used in all segments of the bridge. The casting platform is a temporary structure constructed on top of 2 steel launching beams that are cross-braced and supported by several sets of sacrificial-driven concrete piles. The launching beams extend beyond each end of the cast platform, providing a 25-metre prefabrication table for reinforcement at one end and a 30-metre launch deck at the other that provides part of the cantilever mechanism for the launching process. These beams are tied into a concrete thrust block cast against the back of the abutment, which prevents the entire launch and cast deck from moving backwards during the jacking procedure for the bridge launch. Mounted on the launch beams at the casting platform is hinged formwork that makes up the profile of the box girder. Once the external formwork and hydraulic base tables have been set into position, the web wall reinforcement is winched up into the casting platform from the prefabrication table. Following this, the post-tensioning continuity ducts are positioned in the walls and the launching ducts and tendons placed into the base. The remaining reinforcement is then placed over this, followed by the internal formwork shutters, which are mounted off the external forms. Concrete is delivered via boom pump, with placement beginning in the web walls, then transferring to the base. The base is then compacted, trowel finished and cured using curing compounds. This casting process takes approximately 5 hours. The following day, the internal wall forms are removed to allow positioning of the prefabricated steel internal soffits, which are used to support the deck cast. Once the internal deck soffits are in position, the bottom mat of deck reinforcement, including the ligatures for the cast in situ parapets, is placed, followed by the transverse dressing and longitudinal launching tendons. The top mat of deck reinforcement is then placed and screed level rails installed. Concrete is placed via boom pump and vibrating power screed to ensure accurate level control and compaction. Once the concrete deck has achieved initial set, steam distribution pipes are placed over the deck and connected to a steam generator. Prefabricated steel frames with canvas covers are then placed over the deck and pipework, creating an enclosed chamber. Steam curing of the deck is begun and lasts for approximately 15 hours. This moist atmosphere accelerates the curing and strength development of the concrete and allows a 7-day concrete strength of 35 MPa to be achieved after only 1 day's curing. The overnight steam curing process creates a unique fire-like spectacle as the steam rises from the cast deck between the floodlight at the end of the cast bed and the time-lapse camera. Once concrete strength of 35 MPa has been achieved, the transverse deck and longitudinal launching tendons can be stressed and grouted. Hydraulic jacks are used to apply the required load to the tendons. Liquid grout is then injected into the ducts and sealed at high pressure. The launching tendons connect the segments together to form a continuous beam, readying the box-girded bridge to be pushed out over the river. Once stressed and the formwork released, two 600-ton capacity hydraulic jacks are placed behind the segment on the launching beams. Together with ram extensions, each segment is jacked forward a maximum of 3 metres before the jacks need to be repositioned. Directional movement of the bridge during launch is controlled by lateral guide wheels mounted on the launch beams on the launch deck. The concrete segments simply slide on top of greased sheets of plywood board located between the box girder base and launching beams. Segments can weigh up to 300 tonnes and consist of 90 cubic metres of concrete and steel reinforcement. The jacking process takes approximately 4 hours to push a full segment of box girder out of the casting platform. Attached to the front of the first segment of box girder is a sacrificial prefabricated steel launch nose. This 43-metre long tapered nose is designed to act as a guide and cantilever lifting beam for the box girder launching process. As the equivalent length of box girder weighs approximately 600 tonnes, 6 times heavier than the launching nose, this acts to significantly reduce the amount of sag experienced in the box girder during launch by transferring part of the bridge load to the bridge pier at an early stage. As the launch nose moves across the pier, the tapered profile acts to raise the box girder back to its correct level, allowing it to slide effortlessly across the pier. The launching nose weighs approximately 92 tonnes and cost around $350,000. In addition to the launch of the Melbourne-bound bridge, you can observe the placement on the adjacent bridge of cast in situ concrete parapets. This specialised mobile jump form enables the formwork to simply be pulled from section to section, allowing a continuous cycle of 12-metre sections to be poured each day. There are 2.5 lineal kilometres of bridge parapets on the Victorian section, which meant that this efficient method of construction was critical to achieving completion ahead of schedule. Upon completion of the launch, the box girder internal diaphragms are cast over the bridge piers and the bridge post-tension. Post-tensioning is achieved by stressing the tendons in each of the 4 continuity ducts in the web walls to the required load using multi-strand hydraulic jacks.